Next part, fields.
This one. This one's going to be like pretty, even more informal. So. Okay. I'm going to do a second talk. Sorry, everyone. Second one's going to be about some of the stuff we've been doing on the engineering team maybe over the last 2 years or thereabouts. Yeah, I work at this company. We're in downtown. The dev team is fully remote. The dev team is fully remote. We have 10 full time. We've gone over the last 2 years from 3 engineers up to 10 full-time engineers and 2 full-time designers. We use the PHP stack, as people like to say, jokingly, which is Postgres for the data layer, Haskell for the backend, and PureScript entirely on the front end for the most part, with some bits of legacy JavaScript stuff here and there. This one will be. This will be pretty informal, so again, just tell me if you have questions and stuff. We can start. There's a lot of slides, but I'm going to try and run through quite a lot of it. So, the current status is the data layer is all Postgres. Mostly, the access to the database is 100% typed, all via Haskell. There is a little bit of handwritten SQL around the edge cases, but around the edges to handle stuff we can't quite do in SQLite system, but the vast majority of it is actual queries written in typed Haskell. Backend is the vast majority, more than 95% is Haskell. A little bit from the old stack, which is Node, just mostly proxying various things, but the vast majority of backend is Haskell. About 56,000 lines at the moment of Haskell. Front end is, currently the metric is about 85% PureScript, 15% JavaScript, and we have 62,000 lines of PureScript to give you an idea of the size of the application. But actually it's a little bit better than that, it's kind of a misleading stat because we actually have 2 main applications that we write. The newer one, which is the one where we got to do more of the PureScript stuff, we had fewer legacy constraints, is currently at 97%, so it's 97% PureScript. 3% is a little shell around the edge of hooking stuff up into React using the FFI and routing table, this kind of stuff. And then the older app, which we are now backporting a lot of these ideas and things that we've learned into, is currently 63% PureScript, and the rest is JavaScript. So I'm just going to talk a little bit quickly about how we got here, because I think it's interesting. We didn't wholesale rewrite anything. Everything it really has been a incremental rewrite to get to this point. I think it's kind of interesting. So the initial version of the stack was really different. When I joined the company, we used RethinkDB for storage, or Postgres, and we used Elasticsearch for indexing the data. So you can do some basic. I don't know what the support for indexing is in Rethink. I'm not an expert in Rethink by any means, but I think this was a very common architecture, which is NoSQL database with Elasticsearch stuck on top for adding indexing and searching and stuff to it. We had a Node backend using Express, I think, and an entirely JavaScript-based frontend. PureJS, no TypeScript, anything like that.
Use jQuery?
It was React. The JavaScript frontend was all React-based. It was at least using ES6, so Babel transfer. We did have some functional stuff going on. There was an interest in functional programming, even at that point. So immutable, all the data structures using immutable JS, Lambda, which if you're not familiar is a FP in JS library. Just for some basic functional programming capabilities like query functions, functional folds and maps on arrays, this kind of stuff. I believe, although I wasn't around for this, that we tried Elm, and I asked for some context on why we didn't use it, and the answer I got, like, I guess nobody could fully remember, but the answer was like quotes were difficult to use without data, and I don't know enough about Element to like say say much about that. But apparently we tried Element and it didn't quite work. The quotes were a bit tricky. So when I came in, we had this JavaScript front end. It was, like Eric said, it was all React based. We had this custom Redux-like state manager that was like written like in-house, and it wasn't Redux, but it was sort of Redux-like, and it's like this sort of global state added on top of React. This proved to be like kind of a pain for migrating, so that's sort of why it's relevant. It kind of got in the way quite a lot. So at the time, this stack was sort of working just fine. Like the application was reasonably small. Like it was working fine. Like you keep, I think, a lot of the constraints in your head when developing. So it didn't have a lot of the problems where a typed language would have come in really all the handy solving problems. Like you maybe can keep track of like all the constraints in your head. You want compilers to do it for you. But as the project grew, obviously, we got more to the point where we would get benefits from static types. So this was around mid-2016. And then step one, around mid-2016, this was before I joined the company, the company decided to try out Haskell on a new project. So we had the one main project and then a new separate project started, which was sort of like a back office application, like not a customer facing project. So it sort of afforded us a few more opportunities to try a few weird and more interesting things. So Brandon, who was the first hire and was working on stuff, decided that he wanted to try Haskell on this new project. I asked him why, and he said, usually we try Haskell in his spare time. He likes using it. Had a bunch of sort of relatively common answers for like why he wanted to try Haskell. So he had used it and like seen the benefits of like refactoring. Knew that like types were great for like verifying correctness and all that kind of stuff. And he also sort of jokingly said, I hate writing tests when I can compile and do it for me. So we do have. We have a few tests. We definitely don't do like TDD or anything like that. We don't have like a very test-heavy code base by any means, but we rely on types like a lot. So we get a lot of correctness from the type system. If we find ourselves in like a situation where I would say like if we find ourselves in a situation where we need to add correctness or verifiable correctness, and there's an obvious path like using types, we'll probably try and push stuff into the type system rather than adding a pile of tests to like. So I have a few examples of that I'll talk about in a little bit. Okay, so this new project was an all Haskell backend, all written in Servant, and a new API written in Servant for this data entry back office project. Apparently Servant at the time didn't really have much in the way of like authentication support, so it was like a custom authentication layer that I believe is now gone. Now I'm pretty certain that's now gone, but at the time it was Servant with like custom authentication and various things. We had a custom data layer that was talking to RethinkDB, so the Haskell support around RethinkDB was probably like, I think not like fully built out or like almost non-existent, so I think we helped out like building some of the support for RethinkDB. And we had like, there's some custom code because like RethinkDB, you can't, there's sort of limits on like how much, we found there were like limits on how much computation you could do in the database, so we found ourselves using triggers and things to like compute data on insertion rather than computing it at the time of query time. So we ended up with this sort of like slightly weird custom data layer where for like a sort of DSL for writing triggers and pushing them down into RethinkDB and all this kind of stuff. And as I'll talk about, this sort of ended up going away. Like Eric said, we used Elasticsearch at the time, so we had, if anyone was familiar with the Bloodhound libraries, that was a great library to use. Like, I mean, given the fact that we had to use Elasticsearch, or we'd already made the decision to use Elasticsearch, like, I think Bloodhound was like as nice a layer as you could possibly put on top of that. And this new app also, like we were still using JavaScript at the time, even though we were starting this new project. So I think at the time we had some flexibility in like backend, in the choice of backend language, but there were some constraints from like the structure of, let's say, the business on the choice of front-end languages, because we had front-end developers who were not familiar with, let's say, PureScript or Elm, that realistically wouldn't have had the time to learn it, and even like non-technical people writing, for example, CSS. So people who can write code, but that might write a lot of CSS, for example. And if we'd have gone with, let's say, Elm, which I think, again, I wasn't here, but like I was in the company at that time, but like if we'd have gone with, let's say, Elm, they wouldn't have been able to continue doing the design in the way they were currently doing it. So, you know, the options available to us now as like a team of 10 people were like not available at the time. So we, you know, at the time we were stuck with JS. And the approach to the front end was the same approach as before. So React plus custom Redux like global state thing. Okay. So this was built, and then I joined the company in I think May 2017, and then yeah, soon after in mid 2017, you know, I'd already sort of hinted like Rethink was starting to show its limitations, and it was sort of becoming more and more obvious because the computations we were trying to push down into Rethink were like really causing problems. Like we couldn't. It was fine as sort of like a document store, but like as soon as we wanted to do any real computation inside the database, we were like running into problems. And like Rethink would just like crash in production when you like issue a query or something. Like, so I made a case at the time, so mid 2017, that we should sort of replace Rethink DB that was sort of outgrown its usefulness, and we should look at like a more industrial strength database. I hadn't used Postgres at the time, but like I was sort of familiar enough with it that like I was pretty confident that it would be a good choice. So we went with Postgres. And like I already said, like the custom data layer was getting a little bit cumbersome, like writing triggers and like pushing triggers into Postgres to offset this like lack of ability to compute stuff was getting a little bit cumbersome. Some other constraints that we had. So interestingly, like Rethink is untyped, right? Like it's made for Python, JavaScript. The untyped nature of its API is like actually was like a big benefit, right? So if you think about, I have a database and I want to provide an API that lets you filter like a table or sort a table or something, right? I can refer to like the properties. Let's say it's a document store and the documents are quite nested. I could refer to like the properties on the objects that represent the documents. Like say, you know, foo.bar.baz should be greater than 42 would be a filter, right? So like in an untyped language, I would just be able to say foo.bar.baz, and it would sort of at runtime, you know, either access that thing or push it down into the database. It's like an untyped thing. But in Haskell, in a type setting, let's say using a system with Haskell types on top of persistent entities and using Escalito, like typed access to the database, it actually becomes really hard to take like data off the wire, like represent like foo.bar.baz is greater than 42. Make sure it exists at the right place in the like JSON you stuck in Postgres, and at the same time verify that it's like an integer, so you could even say greater than 42. Right, so that was something that Rethink made really easy, but Postgres and specifically like persistent and Escalito on top of Postgres did not make it easy to sort of figure out how to do that. Already told you that we chose Postgres, but those were the constraints that led to the decision. Any questions? So another benefit, obviously, we chose Postgres because like the support in terms of things like Stack Overflow, IRC, etc., we expected would be pretty good. Right? The community's very large online. It's known to be like very well optimized, right? It's got a lot of support in terms of like academia and industry, sort of putting resources behind it to like ensure performance and things. So we were confident that it would be fast. We didn't realize like how fast it would be actually. It was sort of ridiculous, but and also like the JSON support was good out of the box, so you can you can just, we were a little worried, a little concerned when we were choosing a database that like some of the document database capabilities of Rethink would not be available in relational databases. So it turns out that there's a type in Postgres called JSON, another one called JSON B for binary JSON, that you can give things that type, and then you can issue JSON queries. So you can say like, give me all the rows where this particular JSON document in this column has, I can literally say foo.bar.baz is greater than 42, and it'll look inside the JSON and verify that. And I can even sort of, in combination with some of the more custom indexes that are available in Postgres, I can even make it such that like the JSON is indexed efficiently to make queries like that fast, which I think is kind of amazing. We sort of didn't realize how fast it was going to be. It was like sort of way faster than we expected. The JSON performance actually like exceeded Rethink DB, which was sort of ridiculous. We realized that all these cases where we were previously using triggers in Rethink sort of went away. We didn't need to like worry about anything to do with triggers anymore, although obviously Postgres has triggers, right? So we had the option if we ever needed it. So that was like a whole sort of source of complexity that just sort of went away. But the amazing thing was we were able to just like wholesale get rid of Elasticsearch at the same time. So yeah, Postgres, even like with the complex computations we were like performing and sticking into Elasticsearch for indexing, Postgres was like outperforming Elasticsearch, even then. So we were able to get rid of both. What's particularly cool is like Postgres also has like full text indexing, which is like a feature that I don't know if people are aware of, but so we could even do like some of the full text search things we were doing in Elasticsearch inside Postgres instead. So that's pretty cool. So we replaced Rethink. So at this point we're Haskell on the back end for all intents and purposes, apart from this legacy application. We had Postgres as the single source of data. Actually, that's not quite true. We also have Redis, but eventually got rid of that. And the approach was mostly working. Things were like, in my opinion, like significantly better. We could like write far more complicated like statistics code and all this kind of stuff. But the front end was becoming a bottleneck at the time. All right. Yeah, the front end was becoming a bottleneck. So step 3 was replace JavaScript, and obviously, this is the sort of thing that I'm particularly interested in seeing happen. So I was particularly excited about this. But this was something that was like, we knew we wanted to do it. We were sort of seeing the pain points of using a lot of JavaScript on the front end, but the reality of it was, not trivial, and it took us about 18 months in total. So first step, sub-step, was decide on a replacement. So, I worked on PureScript. I'm obviously like very biased. I wanted to see like a large industrial application of PureScript. So I wanted to sort of not force this and like keep it kind of democratic. And we went through some possibilities, sort of whiteboarded some different options, pros and cons, etc. We talked about TypeScript. We actually gave TypeScript a good go. We found that it was, I've used TypeScript like extensively actually, like on pretty big applications, and I think it has a lot of benefits compared to JavaScript. It can definitely work. My experience is that it's sort of a little bit too easy to like fall into like the any type trap, right? And like when you find yourself, let's say, dealing with foreign data or something, or like the case I mentioned with like foo.bar.baz, so just give it an any type and like carry on and come to, maybe I'll come back to it later, but we never do. And we found this was happening, right? We gave somebody the task of like, go see if TypeScript can work, try it out with some modules. And so I mentioned like this global state manager that we had, right? Like that's probably one example where like it would have just been too easy to like turn off the types in too many places, and like really it would have been like the task of like moving the thing to TypeScript was like a global program transformation, right? Like it's not possible to do it in like small pieces, and it's not to say that TypeScript could not have worked, but it was too easy to do things the lazy way and too like effective to be lazy in the short term that like it just probably wasn't going to work out. Next option was Elm. So at this point there were 3 of us, I think, when we were making this decision, and we all had a decent amount of exposure to Elm, PureScript, GHC.js, and sort of knew the trade-offs. So I've said quite a bit about like pros and cons of those 3 options, but I knew sort of going in that like, we definitely could have made that work, certainly, but given the sort of features I wanted in the language, and I knew I'd want to sort of like try a few ideas out, sort of like generic programming, lenses, type level programming, all these things that I knew, like, you know, type classes even, like, were not going to be available. I was sort of fairly confident that I wanted either PureScript or GHC.js for that reason, and thankfully, like, everybody agreed on that, so there wasn't really a point of like contention. GHC.js, similarly, like I'd done some small amount of development in GHC.js before, and like I had the opinion, and it was like, you know, other people had the opinion that it was like maybe not quite production ready, although I'm sure that's like would be debated by some people. Like, if, you know, I didn't particularly want to get into like Nix and all this, you know, kind of stuff to like use GHC.js, and like I did like the option of having to, you know, being able to like debug the JavaScript and all these kind of things. So, I mean, I can dress it up, but I really just wanted to use PureScript, right? So, we use PureScript. Right. So the next step was, you know, prove it's a feasible option. So there were a couple of little tasks we set ourselves to try and prove that like this was actually like realistic. So we built a little React wrapper. This eventually grew into React Basic. I found the initial commit. Here it is. So this was actually like ripped out of the repo. I'm not going to be able to see this. So this is like, this was React Basic version, you know, 0.1. Very, very simple. You could create an element. There were a few foreign types, you know, JSX here. By React, create element, no children. We had synthetic events, we had CSS. So this was very, very basic, but it was enough to like have a button and click on it and kind of do some stuff, right? So I added this. And this was enough to be able to port. So I'll move this. Oh yeah. So even back then we were doing code generation to get the props and like type check the props, right? So this was one of the initial features, and one that sort of stuck around in React Basic is that it lets you provide only the props you need on React components, but if you do provide the props, it will type check them for you. So it uses this, if you're not familiar, this union constraint idea can be used to express like constraints of that nature, where, you know, it's optional but validated if you provide it. So this was, even though this was sort of very, very basic, it was enough to express some of the stateless components that we were like trying to port over as a proof of concept. Yeah, we ported some of the simple stateless components, but even then, like this like global state thing was there in the background. It's like we sort of knew this was going to be a bit of a problem, and we found ourselves having to just sort of find tricks and like workarounds to like maybe like pass in state update functions as arguments, and use some tricks to like get around this, and like until we could port enough of it that we could just remove the state manager piece all at once. So that was always a bit like, that made things unnecessarily difficult, but you know, we were able to do it eventually. We also ported some of our forms. So there's two types of forms we have in our application. This is, you know, it's a data entry application at its heart, so it's pretty forms heavy. One of them is a rich forms DSL that we have. It allows for things like validation. It allows for monadic forms, so you can have, there's actually two DSLs. There's an applicative one, which is like the state of the form, the shape of the form never changes, and there's which is great for like in React, especially because you don't have to like worry about keys changing and things. And then there's a monadic one where the shape of the form can change if the values change in the preceding form elements, right? So I can say, let's say, pick a country, and then pick the state from the set of states or provinces in that country. Right? So that would be an example of like a monadic form that you can build. And then we also have, for more basic forms that are just like pure data entry, no validation, we have a type level DSL that, you know, the applicative DSL and the monadic forms DSL are really good for when you want to be very, very specific about like validators and have like fine-grained control over everything, but it gets a little bit verbose, so you sort of find yourself doing the same thing over and over again. Whereas if you just have like a type and you want to say, give me a form for this type, it's sort of easier and sort of more appropriate in some cases to just have this type level DSL where like a lot of the form can just be derived. So you lose the flexibility but gain like speed of development, for example. So we have these two different complementary approaches. Probably show a bit of that. This is, I missed this, but this is React Basic. If anybody's interested, this is the library that I was just talking about. This sort of what powers all of our modern all of our new front-end development. So it's the tagline is an opinionated set of findings to React Library optimizing for the most common basic use cases. So we're not trying to like wrap absolutely everything here. It's made for sort of it's made to be easy to use in the most common cases. But we don't trade off that much, and it's totally usable for real-world applications. We use it for all of our new front-end development, and other companies have picked it up too, which is awesome. And if you want to see the forms DSL, it generates stuff that looks like this, which I think is it's pretty nice looking. So you see this validators here. First name should belong. So you do all sorts of validations. Then, yeah, passwords do not match, etc. And there's a lot of, we've added quite a lot of capabilities to this. So you can have like inline forms, right? So you can have like 2 addresses, and then I can like delete one of the addresses. Asynchronous pickers. What else have we got? Oh yeah, file uploads. And then there's actually an extension of this, which I think is really cool. Which we have a bunch of blog posts on this. If you go to Lumi.dev, this will go into far more detail about this stuff. But I mean, the high level, we have a forms DSL. We also have this wizard DSL, which is kind of neat. So if you, we found ourselves wanting to like split up a form up in multiple steps and not show it all at once. And we spent a while sort of like thinking about what the DSL would look like for this, and like trying out like different monad transforms and stuff. And it turns out if you just like apply the free monad type to the existing applicative form DSL, you get the perfect thing, right? Like the free monad is just a series of steps, each one of which is described by the function we pass in, and the function we pass in is a form. So you get a series of steps, each one of which is a form. And it just like lines up really nicely, and then you can like, the interpreter allows you to like add next and back buttons and sort of step through. So so you see, like move on to the next step. Wait, inches. Not great UI. But you get the point. So we have these different primitive things that we can use to build these forms. So it's pretty cool. I can't show the type level thing, which is a little unfortunate because it's not in the open source repo. Okay, and then we proved that like at the low level, like just in the small level, was like build like components and things, but we wanted to build like real projects with it. So we decided to implement an initial project, like a real like take one of the projects that we were taking on as a team and like write it using React Basic and some of these components that we were reporting. We needed to share types between Haskell and PureScript, and we knew there were some options. So if you've done this kind of thing, there's like servant PureScript. There's actually I'm not entirely sure some other options. I think there's another one, but I can't quite remember. We looked at servant PureScript, and it was probably possible to use it, but it didn't quite fit our use case. And so what we decided to do was build this custom code generator. So there's a library called servant foreign, which is it basically takes your servant type definitions and turns them into value level representation of the API types that you can use to basically do code gen in like whatever language you want. So we used servant foreign, and we took those data structures we wrote a custom code generator that generated PureScript code. So we added a few niceties to it. So for all the record types that showed up, we generated lenses. So we had like a library of like all the lenses we might ever want, so we didn't have to like bother using like the slower implementation, like the record polymorphic lenses that the ProFactor lenses library gives you. But it was, it was not particularly difficult. Like everything just sort of fell into place. It was really well. Next step was sort of building more of the foundations, just making sure all the building blocks, if we were going to adopt this as a team approach, were in place. So React Basic by this point was becoming very much like a real library, and we were using it more and more. I already said the tagline is this opinionated wrapper part of React. We'd started work on what is now the Lumi components library, which I sort of showed but didn't really show properly. So this was the wizard, and I showed the form, but we have all sorts of components this is open source, by the way, PureScript Lumi components. All sorts of components that we would use throughout the application to have a consistent look and feel for everything. So one of the really cool ones is table, which I like. So it has it's a little bit small. It has some nice features, so you can have select down the left, and it has sticky columns, so you can keep the identity of things in focus while you look at the other stuff. It has a compact mode. You can pick the columns you want to see, reorder them. So it has a lot of nice features, right? And this is open source now. We made the decision not to sort of develop this as an open source thing in the sense of it is open source in the sense that the code will be available, but we're primarily trying to optimize for our own use cases. So it might not be the most, it might not be the best sort of example of an open source component library. It might be a little rougher at the edges, but we'll see where it goes. And we're definitely interested to take suggestions on the issue tracking and all that kind of stuff. Have discussions about where this could go. Where are we to? We're doing on time. Almost over. Yeah, so again, opinionated, an opinionated set of UI components, but hopefully useful for use cases that are very close to our own. Next step was to port some existing components, of which we had a lot, and this took a long time. So when I say components, I mean both pages and components. Bearing in mind, now we're at 62,000 lines. Optimistically, maybe we were at 40,000 equivalent at the time. Porting 40,000 lines equivalent of JavaScript was, was quite a lot of work, especially considering we had this global state manager thing in the way that was making everything difficult. On the plus side, we were able to open source a lot of components, so we open sourced some wrappers around React things that we were using as temporary solutions while we built up the Lumi components library. So the React drag and drop library has a nice wrapper now that we are we still using that? Actually, I'm not sure. Yeah, we're still using that a little bit, and then React Select, we wrote an open source wrapper around that. So we're able to make some small contributions before this large Lumi components contribution. And the last step, we wanted to really take advantage of the fact that we now had everything in type language. We had the ability to do things that were really just infeasible in JavaScript. So the forms DSL was probably the biggest example of this, and type level programming for forms that I mentioned already. Type level programming for well-typed forms, just for the most basic cases where we're essentially just doing data entry. We're able to build a type level DSL and synthesize the types of the form state and sort of line up the form layout at the same time, which was really handy for turning around. We had a lot of sort of data entry type forms that we wanted to get done very quickly, and it allowed us to make a lot of progress very quickly on that task and then come back and sort of tie it up later. Another thing that we would never been able to do in JavaScript that we can now do is type safe routes. So if you're familiar with YSOD and the way that YSOD lets you have type safe routes, so for example, you can't link to something within the same application that would give you a 404. We wanted that same functionality on the front end, so we wrote a wrapper around React Router that would verify that we couldn't link in-app to things that would give a 404 in our single-page application. We haven't open sourced this yet, but I'm hoping we can really soon. And then, next steps are basically look for more opportunities to exploit types. Basically using types as a tool, not not just using them as like verification, but like actually like a tool to make us faster as a team. I think some of these are going to like require a bit of a shift in the way the team as a whole thinks. So like getting the product team to like internalize the idea that like we now have this new tool called types, and like, you know, people use Excel, right? Like nobody thinks of like sum types, for example, when you're writing like Excel spreadsheets as prototypes of features and things. So like it's like a whole tool that like people don't have in their toolbox. You have to sort of have a bit of a shift in thinking to realize that like, hey, you've got these like super powerful new tools you can use. And then, you know, I mentioned we had this legacy app. We want to go back and like apply some of the stuff we've learned and like make a consistent framework for like building the next app, right? So we're not doing things 3 times. And then I was sort of thinking to myself, like, you know, it's kind of like this embrace, extend, extinguish idea that we've, like take for example like React, right? We embraced it because we used it, we extended it because we built React Basic, but now like we don't really need React anymore because we only really use this API, right? Like the Elm architecture that sort of underlies our application is enough, and there are like hundreds of implementations of that, right? Like some of them don't have the same runtime errors that React has when you like, you know, have like a loop in the mounting logic or something. So like using types and like building this like really solid foundation, I think affords us some interesting options like not using React, or like another example would be we've thoroughly encapsulated, did I write these? No. Like really encapsulated our database very well at this point. So like the internals, like the surface API is all that matters, right? So we could easily like, we don't need to use Postgres anymore. We could like replace Postgres with something else. So like, not that we're probably going to replace Postgres, but like we could replace the exact, like, we could replace the way we do certain things in the database very easily. So I think using types, like, not that you can do this with types of course, but like it's an easy way to structure your thoughts around like APIs and encapsulation and all these kinds of things. That allows us to like get rid of some legacy decisions possibly. A few challenges, obviously when you're writing, you know, making your own sort of stack up as you go along, there's going to be missing libraries. We had to write a whole bunch of stuff that was not available off the shelf, or wasn't quite on, you know, on the shelf wasn't quite the way we would have wanted it to be. We find we're sort of pushing the compiler to its limits in a few cases. So I already mentioned like type level programming is probably the biggest example of this. Dictionary elaboration from type level programming has kind of gotten like really ridiculous in our code. Like the other day, I managed to like get Webpack to just like freeze for like 30 minutes, trying to like, and it turned out to be like something to do with dictionary elaboration, because like I like changed the way the code was written so that like there wouldn't be as many dictionaries, and then Webpack was like perfectly happy and like, you know, packaged up the code. So it turns out it was generating like 20 megabytes of JavaScript or something horrible, and then like error messages are utterly ridiculous in some cases. So like it was. Like you'd think the compiler had frozen, but then like 2 minutes later it would spit out an error message that would literally like overflow the console history, and like it's just, yeah, it's silly. But so we find ourselves like, you know, fortunately we have 2 people on staff that are like very familiar with the PureScript compiler internals, so we could like, if you know we see opportunities to help ourselves with some of that stuff, we probably will send some PRs, but. Yeah, fortunately, you know, we can trade some stuff off between PureScript and Haskell and maybe find a solution that way, but that's definitely been a challenge. Like, you know, you give yourself all this expressiveness with, like, for example, type level programming, but it comes with a cost. Another sort of relatively obvious problem is hiring. It's not been terribly difficult to hire people so far, but like, you know, being remote has definitely helped. I would say it's like essential for the type of team we're building. We have to be ready to train, so we do like Haskell and PureScript training. At one point we're doing it like 3 times a week. We've kind of cut down a little bit lately. So, you know, with that, being ready to train people and hiring remotely, I think like hiring has been fine, but you know, it's just something that we have to be aware of. Those are the main challenges, and I'm done. So if anyone has questions.
You mentioned that you have like this Mavic DSL for describing forms, which might change based on the policy. So have you looked at the new paper about selective applicative factors?
Yeah.
I was looking into that case. We don't really need one.
Yeah. So the question was, are we aware of like the selective applicable functors work, and does it make the monadic form stuff not necessary, right? I think probably yes, it probably does make most of the use cases for monadic forms not necessary. We have looked at it, but we haven't like looked at it very seriously yet. So we'll probably, I think we'd like to. That would be probably a fantastic PR on the Lumi components library, honestly. We'd like to sort of like demonstrate that that's like, that works and can simplify a lot of code, but we'd totally be up for adding that as an API